Sir, shall we start the session, sir? Sir, unmute பண்ணுங்க sir. Sir, உங்களுக்கு unmute பண்ணுங்க sir.
Start பண்ணலாங்க. Start பண்ணலாம்.
Okay. Very good morning to one and all. Welcome Professor Dr. G.S. Triñanam and participants. Welcome to the third day webinar on durability of concrete advanced techniques. All are cordially invited for this webinar. Now I am going to introduce our Professor Dr. G.S. Triñanam. Dr. G.S. Triñanam was the former principal of the Institute of Road and Transport Technology, E-Road. He had his UG during 1982 at Madras University. He had his PG program in structural engineering during 1984 at Anna University. He completed his PhD during 2002 at Bharatiyar University. He is having 34 years of teaching experience and 20 years of research experience in Institute of Road and Transport Technology, E-Road. And currently he is working in Builders Engineering College for the past 2 years as professor. He published 41 research papers in international journals and national journals, presented more than 100 research papers in national and international seminars and conferences. He is holding membership in Indian Concrete Institute, Indian Society for Technical Education, Institution of Engineers, Institute of Urban Transport, International Center for FRC Composites. He completed more than 100 ME projects. He guided more than 100 ME projects. And he guided 12 numbers of research scholars, including me. His area of interest is concrete technology, special concretes, seismic behavior of concrete, steel, and composite structures. He has undertaken consultancy work connection with concrete mix design for buildings, highway bridges, concrete pavements, and canal linings. He is reviewer and editorial board member in International Journal of Earth Sciences and Engineering, elsewhere Springer Journals, that is Construction and Building Materials, Fracture Mechanics, Arabian Journal of Science. He is member in Board of Studies at Anna University, Annamalai University, Karpagam University, Nurul Islam University, Karunya University, and autonomous colleges. He is a research committee member in Anna University, SRM University, Karpagam University, Nurul Islam University, Karunya University. He has conducted webinars on role of civil engineers, earthquake resistant design, special concretes, rehabilitation, structural design, bridges, NDT, etc. He is having vast experience in all fields, and IRTT is the one among the premier institute in conducting structural elements. He guided so many ME students and also PhD students. We all can be benefited from the lecture from our professor. Now I welcome Dr. G.S. Triñanam sir to deliver the seminar. Thank you very much. Thank you, sir.
Thank you very much, Sanmugam, for the nice introduction. And good morning to all. First of all, I wish to thank the management of Shakti Polytechnic College and the civil department organizers of this STTP program for giving me the opportunity to talk something about the concrete technology, recent innovations in concrete technology. Concrete is the base material which is used in construction, and it is the second material which is consumed in the world after the water. So from this, you can understand the importance of the concrete. Concrete is consumed very much quantity next to water by the human being for all infrastructures and for all other civil engineering works, etc. The concrete is the base material. So we civil engineers have to use the concrete material means we thoroughly understand the properties and behavior of the concrete in different types of environments and different types of applications, etc. That is the purpose of this STP program, Recent Innovations in Concrete Technology. So over this period, 5 days, you will enrich your knowledge on the concrete technology. Now we will go to the presentation. Durability of concrete, advanced techniques. So what about the definition? The durability of cement concrete is defined as its ability to resist weathering action, chemical attack, abrasion, or any other process of deterioration. Concrete is normally deteriorated due to the time and aggressive environment. So it is the resistance to the process of deterioration. That is the definition for the durability. Durable concrete will retain its original form, quality, and serviceability when exposed to its environment. So it retains its original form, quality, and serviceability when exposed to different types of environment. So these slides, these pictures shows the consequences of inadequate durability. You can notice the concrete structure has been deteriorated like this. That is the lack of durability. So lack of durability causes the spalling of the cover concrete and exposed to the adverse reinforcement and other interior of the structure. So column bars, ties, etc. are exposed. The cover concrete is completely spalling off. So it leads to the corrosion of the reinforcement and finally the failure of the structure. Failure of the structure. To achieve good durability of reinforced and pre-stressed concrete in aggressive environment by specifying high cement content, low water cement ratio, suitable minimum thickness of the cover to the reinforcement, and careful curing. So to achieve the good durability of the concrete in aggressive environment, you have to specify higher cement content, lower water cement ratio, and minimum thickness of the cover, and the curing, importance of the curing. Higher cement content means our code of practice for the plain and reinforced cement concrete, IS 456-2000, is giving emphasis on the durability aspects of the concrete. The previous code, IS 456-1978, is not giving much focus on the durability of the concrete, but the revised code, IS 456-2000, is completely based on the durability requirements. So it specifies the different types of exposure condition: mild exposure, moderate exposure, severe exposure, extreme exposure condition, etc. And it gives in a tabular form what about the cement content, minimum cement content needed, what is the maximum water cement ratio, etc. So higher cement content is depending upon the exposure condition. For mild exposure condition, it may be about 320 kg per meter cube. At the same time, extreme severe condition, 360 or 380 kg per meter cube of cement. That is the minimum cement content you have to maintain. But at the same time, you should not exceed the cement content beyond 450 kg per meter cube. This is not permitted by both IS 456 and IS 18993, that is the pre-stressed code, etc. The previous pre-stressed code is 540 kg per meter cube, but in the revised code, it has been limited on par with IS 456, 450 kg per meter cube. So whatever the grade of concrete, you have to maintain your cement content. That is also because of the durability considerations. Because higher cement content induces the shrinkage cracks. Shrinkage cracks formed means automatically permeability comes. So durability is becoming deteriorated, less and less. That is, the concrete is susceptible for the deterioration. That is why the cement content is mentioned. And at the same time, the water cement ratio is also mentioned in the same tabular column, maximum water cement ratio for the different exposure condition. For the moderate, mild exposure condition and moderate exposure condition, the water cement ratio may be 0.5 or 0.45. But for the severe and exposure severe condition, it is limited to 0.4. The maximum exposure, maximum water cement ratio is limited to 0.4. So you can normally adopt 0.3 to 0.4 depending upon the grade of concrete. Similarly, the cover thickness of the cover is to be maintained from ranging from 20 mm to 60 mm depending upon the exposure condition. If the exposure condition is extreme or severe, you have to provide a long maximum thickness of the cover, 40 mm or 50 mm thickness of the cover. Then only your reinforcement is completely protected. We will see later in the slideshow for the importance of the thickness of the cover. And another thing is important, careful curing. Inadequate curing is completely necessary. 100% curing is necessary. If the curing is not up to the mark, up to the satisfaction, or inadequate curing, then there are so many honeycombs or voids, capillaries, etc. are present, or cracks, etc. are present. That leads to the deterioration of concrete. So you have to give importance to the curing method. So what are all the structures? It is meant for durability, is meant for all the type of concrete structures. Out of this, the prestigious concrete infrastructures include highway bridges, nuclear reactors, elevated water tanks, multi-story buildings, etc. These are all some of the structures. For example, Mumbai Bandra Worli Bridge, it is situated in the Arabian Sea in Mumbai, connecting two parts, Bandra and Worli. It is exposed to the severe or extreme exposure condition because of the sea water and the sea atmosphere. So you have to give importance to the durability of concrete structures. Similarly, the suspension bridges, the concrete portions, etc. have to be very careful because the durability of the concrete gives longer life to the bridges, suspension bridges. Even though the cables are made with steel cables, steel is also subjected to corrosion, etc. So you have to give durability consideration for this steel also, and this trussed girders also, and concrete also. Nuclear reactor. Normally, we prefer high-performance concrete or high-strength concrete for the construction of nuclear reactor. Here, one of the durability requirement is the radiation requirement. Because if the concrete is poor condition and not in good condition, it is subject to the radiation. The radiation emitted from this nuclear reactor will affect the people working in the nuclear power plant, etc. So you have to build your nuclear reactor and other containment structures, such as radiation shielding, is to be provided. That is one of the durability requirements. This is the view of the containment structures. And multi-story buildings. Nowadays, multi-story buildings are very common in the metropolitan cities. Recently, about 117-story building has been constructed, is under construction in Mumbai. And if the height of the structure goes tall and tall, high-rise structures, etc., durability requirement is very, very important, because Mumbai and other metropolitans, even Calcutta and Chennai, are exposed to the sea atmosphere, because these are all the coastal metropolitan towns, cities. The modern buildings which are constructed in each of the city, Bangalore or Hyderabad or Chennai or Coimbatore, etc., has to be constructed with durable materials, steel and concrete, etc. Buildings exposed to marine environment. As I mentioned earlier, the marine environment means the sea atmosphere and sea water, etc., which is salt-laden atmosphere. These are easily affected the concrete structures and react with the concrete, that is deteriorating the concrete structures. You have to give protection to the concrete structure by arresting the deterioration of the concrete, disintegration of the concrete. In Bombay High, offshore platforms are constructed for exploring the petroleum minerals, and these structures are erected completely in the sea. So this durability considerations is very, very important, prime important for these structures. And power plants, whether thermal power plants or any other power plants, gas power plant, etc., atmosphere is laden with several chemicals, fumes, etc., high temperatures, etc. So your concrete must be durable for resisting this aggressive environment. Chemical plants, whether it is manufacturing the copper or steel or organic materials or paints or some other medicines, etc., the chemical ingredients are affecting the durability of the concrete. So chemical environment, aggressive environment means chemical environment. These structures are exposed to the chemical environment. For example, sulfuric acid, if it is liberated, that sulfuric acid affects the concrete surface and causes the electricity or disintegration of the concrete structures. So durability properties. The durability properties are affected by the following factors: impact of water cement ratio on durability, permeability, sulfate attack, chloride attack, corrosion of steel, carbonation of concrete, acid attack, alkali aggregate expansion or reaction, frost action, freezing and thawing action, etc. These are all the factors affecting the durability properties of the concrete. Let us see one by one. Effect of water cement ratio. There is tremendous change in the microstructure of concrete made with higher water cement ratio and low water cement ratio. Nowadays, SEM scanning electron microscope pictures are available. It shows the microstructure of the concrete elements. Thus, we will examine the microstructure with higher water cement ratio and lower water cement ratio. With the lower water cement ratio means the CSH gel is completely formed. It reduces the voids in between the aggregates and other things. Capillary pores are very, very less. So it is having durability, higher durability when lower water cement ratio is formed. But at the same time, if the water cement ratio is exceeding 0.5 or 0.6, etc., higher water cement ratio, then the microstructure of the concrete exhibits there are a lot of voids in between the ingredients of the concrete, and porous action will be there, etc. And the atmospheric ingredients, the harmful ingredients, harmful contents from the atmosphere can easily penetrate through the concrete and affect the concrete, carbonation of concrete, chloride ingress of the concrete or sulfate attack of the concrete, etc. And finally, it causes the deterioration of the concrete. With low water cement ratio, the permeability decreases to such a level that these concretes are impervious to water. With low water cement ratio, the permeability decreases to such a level that these concretes are impervious to water. This does not mean that they do not contain interconnected network of capillaries, but these capillaries are so fine that water cannot flow anymore through them. These capillaries are so fine that water cannot flow anymore through them. If the flow of water through the microstructure is prevented, means automatically impervious to water, means the external agents will not affect the interior portion of the concrete. So there will not be any deterioration or disintegration of the concrete. So durability concrete is produced. When such concretes are tested for chloride ion permeability test, it is found that chloride ions diffuse such concretes at a rate of 10 to 50 times slower than that of higher water cement ratio concrete. So if you adopt higher water cement ratio, the chloride ion penetration is much higher. So the specification of the waste and specification of this RCPT test shows that low permeability or high chloride penetration, or it is highly affected the durability of the concrete. Whereas at the low water cement ratio concrete, along with some chemical mineral mixture or the chemical admixture, reduces or the slower the chloride ion diffusion in concrete. So the durability of the concrete is much more higher, about 10 to 50 times higher. It has been proved that low water cement ratio concrete are less sensitive to carbonation, external chemical attack, and other detrimental effects that cause lack of durability of concrete. It has been reported that it becomes impossible to corrode unprotected steel reinforcement in accelerated corrosion test of a concrete with very low water cement ratio. So very low water cement ratio means it is impossible to corrode the steel reinforcement because of the impervious of the surface, impervious of the concrete. So when you done your accelerated corrosion test, also it proved that the rate of corrosion is very, very less when you are adopting the low water cement ratio. Similarly, with low water cement ratio, you can increase the resistance against carbonation, sulfate attack, chloride attack, alkaline attack, etc., and other detrimental effects, etc., which causes the lack of durability of the concrete. So it could be inferred that the best way to protect reinforcing steel against corrosion is to use low water cement ratio and adequate cover, rather than using higher water cement ratio and then protecting the steel by epoxy coating. In this context, the strength and workability criteria are completely reversible. If you want strength, you have to reduce the water cement ratio. But reduce the water cement ratio means the workability is also reduced. So in order to get the sufficient workability is in place of the concrete, you have to maintain some quantity of water. That is the higher water cement ratio. But if you provide higher water cement ratio for workability considerations, but it reduces the strength, Abraham's law shows that the compressive strength is inversely proportional to the water cement ratio. Whenever the water cement ratio is higher and higher, the strength is lower and lower. Not only the strength, the durability is also affected with higher water cement ratio. So if you adopt low water cement ratio, you need not give the protection to the steel by epoxy coating or any other coating requirements. But if you adopt higher water cement ratio, then you have to protect the steel by epoxy or any other type of coating. The effect of permeability. The higher permeability of concrete in the actual structure is due to the following reasons. Formation of microcracks developed due to long-term drying, shrinkage, and thermal stresses. So concrete is normally subjected to the shrinkage cracks. It may be plastic shrinkage cracks or drying shrinkage cracks, and the thermal stresses are also developed in the concrete. These stresses, shrinkage stresses or thermal stresses are developing the cracks. Formation of micro cracks are formed, developed. My formation of micro cracks develop because of this shrinkage and thermal stresses. The large micro cracks generated with the time in the transition zone. These micro cracks generated at the time of fresh concrete goes on increasing with time. So in the transition zone, concrete is transformed from the fresh concrete to hardened concrete. That is the transition zone. So in the transition zone, the micro cracks have been developed, and at the time of application of the load also, the structural stresses form. The structural stresses develops the flexural cracking, etc., shrinkage, shear cracking, etc. So cracks generated through the higher structural stresses. Due to volume change and cracks produced on account of various minor reasons, existence of entrapped air due to insufficient compaction. So the compaction should be sufficient. If there is an insufficient compaction, entrapped air is present in the concrete, and it will reduce the workability of the durability of the concrete. So the use of pozzolanic materials in optimum proportion reduces the permeability of concrete. The use of pozzolanic materials. What are the pozzolanic materials specified by IS 456-2000? Fly ash, GGBS, ground granulated blast furnace slag, silica fume or microsilica, rhesus gas, metakaolinias. Out of this rhesus gas and metakaolinias not widely used as a pozzolanic materials because it is not easily available in all places. But the fly ash, GGBS, and microsilica are easily available, easily procured from reagents. So you can use these materials as a supplementary cementitious material in the concrete and do the mix design. Our IS code IS 10262-2019 mix design code permits the use of these pozzolanic materials, and the mix design procedure is completely illustrated with replacement of cement by fly ash, replacement of cement by GGBS, replacement of cement by microsilica, etc. The examples are given. So you follow this example and do the proper mix design. The optimum proportion is normally specified in the code book also. About 20% or 30% of the cement is replaced by fly ash, and about 40 to 50% of the cement is replaced by GGBS, and only 8 to 10% of the cement is replaced by the microsilica, etc. That is the optimum proportion. The primary purpose is to reduce the permeability of the concrete. If the concrete is impervious, automatically the durability of the concrete is higher. Plastic shrinkage cracks. Water from fresh concrete can be lost by evaporation, absorption by subgrade, formwork, and the hydration process. So during the pouring of the concrete, you can notice that the water is lost by evaporation, water is lost by absorption of the subgrade, formwork, and the hydration process, hydration reaction of the cement. So minimum amount of water is needed for completing the hydration action of the cement paste. That is about 0.25 to 0.3. So this amount of water is completely needed. It should not be the minimum amount of water is available at all the time until the 100% hydration reaction is taken place. So we have to take care of the evaporation loss, absorption loss, etc. Slightly increase the water content, 0.35 or 0.4, etc. If the water is lost by evaporation, absorption, etc., then there is also the minimum amount of water is presently available for the setting action, that is the hydration action. Or otherwise, you have to take care of or arrest the evaporation loss or the absorption or formwork or the temperature loss, etc. When the loss of water from the surface of concrete is faster than the migration of water from interior to the surface dries up. So this is the phenomenon. When the loss of water from the surface of concrete is faster than the migration of water from the interior to the surface. Concrete is water is available inside the concrete. That is, the mixing water is available. This water is inside the concrete. It gradually comes to the surface of the concrete by means of capillary pores, etc. Before that, if the water is completely evaporated, means the surface of the concrete dries up. Surface of the concrete dries up means there will be a drying shrinkage and the shrinkage cracks are there. This creates moisture gradient, which results in surface cracking while concrete is still in plastic condition. The magnitude of plastic shrinkage and plastic shrinkage cracks are depending on the ambient temperature, relative humidity, and the wind velocity. In other words, it depends upon the rate of evaporation of water from the surface of the concrete. So you have to concentrate on this parameter, rate of evaporation of water from the surface of concrete. That is why the practicing engineers are normally following the concrete after 3 o'clock or 4 o'clock when the temperature is receding. So the temperature gradually decreases, so the rate of evaporation of water is also reducing. So your concrete surface of the concrete is completely protected. Otherwise, if you made the concrete, start the concrete process, that is the roof slab concrete process by the morning, 9 o'clock or 10 o'clock, 10 a.m. At the end of the concrete placement, the temperature at the time of about 12 noon or 2 p.m., 3 p.m., etc., the temperature, sunrise temperature is very high, about 40 degrees or 45 degrees, etc. So the evaporation of water from the surface of the concrete is more and more. It causes the shrinkage stresses. So it is the best practice to follow or to arrest the rate of evaporation by suitably adjusting the placing of the concrete. Rate of evaporation in excess of 1 kg per meter square per hour, that is the unit, 1 meter square surface area in 1 hour, 1 kg of water has been considered. The rate of evaporation in excess of 1 kg per meter square per hour is considered critical. In such a situation, the following measures could be taken to reduce or eliminate the plastic shrinkage cracks. So what are the measures? Moisten the subgrade and formwork. So it is normally adopted. Before pouring the concrete, you have to properly moisten, watering the subgrade and the formworks, because the absorption is completely prevented. Water absorption is completely prevented. Next, erect temporary windbreakers to reduce the wind velocity over concrete. If the wind is blowing over the surface of the concrete, automatically the evaporation loss is more and more. So you have to prevent the wind flow over the surface of the concrete by erecting temporary windbreakers. Similarly, erect temporary roof to protect green concrete from hot sun. If the temperature is about 40 degrees to 50 degrees, etc., then temporary roof is erected to protect the surface of the concrete in the green state from the effect of hot sun, radiation of the hot sun. Reduce the time between the placing and finishing. So as far as possible, you have to complete the placing and finishing of the concrete within 1 hour or 2 hours, etc. If there is any delay, cover the concrete with polyethylene sheet. If there is any delay, cover the concrete with polyethylene sheet. This covering will provide the direct exposure to the sun's radiation, etc. So it will reduce the evaporation losses. Minimize evaporation by covering the concrete with burlap, fog spray, and curing compound, etc. Curing compound is some chemical agents or vegetable, etc. That is a spinach or any other essence. This may be added inside the concrete. It will absorb already water, and this water, excess water, is gradually released during the setting action of the cement. That is the self-curing concrete. Similarly, fog spray. Fog is sprayed over the surface of the concrete to reduce the temperature, etc. The effect of curing. Modern high-grade cement, being finely ground with higher tricalcium silicate content, needs early curing, particularly in hot weather conditions. So, if you use OPC 53 grade cement, the fineness of the cement is much more. Because of this, surface area of the cement particles are very high, more and more, and the tricalcium silicate, you can notice the 4 Bogues compound, dicalcium silicate, tricalcium silicate, calcium aluminate, calcium aluminoferrite, etc. Out of this tricalcium silicate is important for the strength and protection. So, with higher C3S content needs early curing. Early curing means after 6 hours or after 8 hours, you will stop the curing. Normally, in the practice, we will adapt the curing after 24 hours or 20 hours. It is not sufficient for the higher C3S content. So, you have to start the curing early, within after 10 hours, etc. Then too in hot weather conditions. Structural members which are thin with large surface to volume ratio, such as sun breakers, charger, etc., needs early curing. So, if the surface area of the concrete is large, you have to start the curing as much as early as possible. Insufficient curing is one of the major causes for lack of strength and the durability of the concrete structure. So, insufficient curing is one of the major causes for lack of strength and durability of the concrete structure. So, the strength is also depending upon the curing conditions. That is the water cement tissue available for the setting action of the cement. Next, effective vibration. It is well known that excess vibration causes segregation, which affects the uniformity of the concrete mix. Excess vibration causes segregation. The fine aggregates and coarse aggregates are separated from the cement paste, and there is no integrity of the ingredients of the cement concrete. This has to be avoided, and you should ensure the uniformity of the concrete mix. These days, high consistency concrete is used either for pumping requirements or on account of using superposition. So, the consistency of the concrete is very much higher, so about 30% or 40% cement consistency. Flowable concrete, the slump is about 200 mm or 150 mm, etc. for the pumping purpose, etc. This is obtainable by using the water reducing admixture, high range water reducing admixtures, or otherwise super plasticization. Care must be taken to vibrate such high slump concrete, otherwise segregation is too sure to take place. This concrete is also a flowable concrete or liquid concrete, so it can be easily segregate the fine aggregate and coarse aggregate from the cement paste. So you have to take very much care to vibrate such high slump concrete. Only very small vibration is needed, other than or alternatively no vibration is self-compacting concrete, SCC. You have to go for self-compacting concrete to avoid the segregation. Segregated concrete matrix divide of the coarse aggregate shrinks more than homogeneous concrete and exhibit high shrinkage cracks. Next is sulfate attack. The term sulfate attack denotes an increase in the volume of cement paste in concrete due to the chemical action between the products of hydration of the cement and solution containing sulfates. The external agents consist of sulfate saltments, and in presence of water, it is a solution containing the sulfate ions. This will affect the hydrated products of the cement concrete, and the chemical action is formed. So the volume of the cement paste is increased. So because of this increase in volume, the deterioration of the concrete takes place. In the hardened concrete, calcium aluminate hydrate (CaH) gel can react with sulfate salt from outside. This product of reaction is calcium sulfoaluminate, forming within the framework of hydrated cement paste. Calcium sulfoaluminate, forming within the framework of hydrated cement paste. Because of the increase in volume of the solid paste, which can go up to 200%, a gradual disintegration of the concrete takes place. Because of the increase in volume of the solid phase, this is calcium sulfoaluminate, which can go up to 200%, 100% increase in volume. So gradual disintegration of the concrete takes place. The rate of sulfate attack increases with the increase in the strength of the solution. If the external solution is rich in sulfate content, then the rate of sulfate attack is more and more. A saturated solution of magnesium sulfate can cause serious damage to concrete with higher water cement ratio in a short period of time. However, if the concrete is made with low water cement ratio, the concrete can withstand the action of magnesium sulfate for 2 to 3 years. So magnesium sulfate is one of the chemical attack on the concrete in the chemical industries. So if you want durability of the concrete, then you have to go for low water cement ratio. Or otherwise, if you adopt higher water cement ratio, means within a very short time, say after 6 months or 1 year, the concrete is completely disintegrated and deterioration is taken place. The concrete is having no durability, lack of durability. The concentration of sulfate is expressed as the number of parts by weight of sulfate SO3 per million parts. 1000 ppm is considered moderately severe, and 2000 ppm is considered very severe, especially if MgSO for magnesium sulfate is the predominant concern. So the magnesium sulfate salt, etc., is normally coming through the water. So the water is strictly under subjected to quality control. If the water contains mixing water or curing water contains more than 1000 ppm of the sulfate ions, then it should not be used for the mixing or curing, because it is considered as a moderately severe, and if it exceeds 2000 ppm, very severe, causes the deterioration of the concrete. Acid attack. Concrete is not fully resistant to acids. Most acid solution will slowly or rapidly disintegrate the cement concrete depending upon the type and concentration of acid. Most acid solution will slowly or rapidly disintegrate the cement concrete depending upon the type and concentration of acid. Certain acids such as oxalic acid or phosphoric acids are harmless. So these acids are harmless, but at the same time hydrochloric acid or hydrosulfuric acid, etc., are the harmful acid attack, and it is deteriorating the concrete completely. The most vulnerable part of the cement hydrate is calcium hydroxide, but calcium silicate hydrate gel can also be attacked. The excess calcium hydroxide liberated from the hydration process is easily attacked by these acid solutions, and it causes the disintegration of the concrete cement paste. Siliceous aggregates are more resistant than the calcareous aggregate. That is one of the prime considerations in selecting the coarse aggregates. You have to, in aggressive environments exposed to the acid attack, you have to select only the siliceous aggregates, not the calcareous aggregates. Concrete can be attacked by liquids with the pH value less than 6.5. So you have to maintain the pH value of the mixing water or the curing water, etc., solution, etc., exposure solution, etc., around 7 or 7.5, etc. If the pH value is less, then it is automatically affected by the acid. It may be carbonic acid or any other type of acid. As the attack proceeds, all the cement compounds are eventually broken down and leached away together with any carbonate aggregate material. All the cement compounds are eventually broken down and leached away together with any carbonate aggregate material. Cement compounds are broken down and leached away. There is no cement content in the concrete. With this may be seen in this video. This is the surface of the concrete. If the concrete is attacked by means of hydrosulfuric acid or any other strong acid, etc., the cement paste is completely leached away and exposing the fine aggregate and the coarse aggregate. This concrete is completely deteriorated and it will not give durability of the concrete. With the sulfuric acid attack, calcium sulfate formed and can proceed to react with calcium aluminate phase in cement to form calcium sulfoaluminate, similar to the sulfate attack, which on crystallization can cause expansion and disruption of the concrete. If acid solutions can reach the reinforcing steel through cracks or porosity of concrete, corrosion can occur, which will cause the crack. That is one of the major points in the acid attack or the chemical attack, sulfate attack, etc. It reaches the reinforcing steel through the cracks or porosity of the concrete. So corrosion is occurring, corrosion can occur, which will cause cracking of the structure and finally failure of the structure. Effect of seawater. The rich concrete with low water cement ratio mainly makes the concrete impervious to attack of seawater, and having very little capillary pores does not hold water to cause expansion either by freezing or by crystallization of salt. So the rich concrete means cement content is higher. High cement content with low water cement ratio mainly makes the concrete impervious to water as well as to the attack of seawater, and having very little capillary pores does not hold water to cause expansion either by freezing or by crystallization of the salt. Provision of adequate cover is another desirable step for increasing durability of reinforced concrete. Use of pozzolanic material is yet another desirable step that could be taken to improve the durability against seawater. A good compaction, well-made construction joints, etc. are other helping points helping the durability of the concrete in seawater. Pozzolanic material means normally GG base, ground granulated blast furnace slag, up to 40% replacement of the cement is the desirable step that could be taken to improve the durability against seawater. So if the concrete is subjected to seawater attack, the structure is erected on the shore of the structure, offshore of the structure or onshore of the structure, you have to mix the supplementary cementitious material, that is GGBS, inside the concrete. So high pressure steam cooled prefabricated concrete elements should be used for better durability. So whenever possible, high pressure steam cooled prefabricated concrete. Prefabricated means the quality of the concrete is very good, and the steam cooled, high pressure steam cooled means it attains the strength as early as possible. 3 days curing is sufficient. 1 day or 3 day curing is sufficient to achieve 100% hydration action of the cement. So it should be used for the better durability. Next, carbonation of attack, carbonation of concrete. In the presence of moisture, carbon dioxide changes into dilute carbonic acid, which attacks the concrete and reduces alkalinity of concrete. Carbon dioxide present in the atmospheric air reacts with water, and dilute carbonic acid is formed, which attacks the concrete and reduces the alkalinity of the concrete. Normally, the concrete has a pH value of about 13. So, by carbonation of the concrete, this will reduce the pH value of the concrete to 9 or 8, etc. The pH value of the pore water in the concrete is generally between 12.5 to 13.5. Depending upon the alkali content of cement. The high alkalinity forms a thin passivating layer around the steel reinforcement and protect it from the action of oxygen and water. So the high alkalinity forms a thin passivating layer around the steel reinforcement and protect the steel reinforcement from the action of the oxygen and the water. H2O and oxygen, etc. are protected. This protect the concrete or the steel from this action. If steel is placed in highly alkaline condition, it is not going to corrode. If the steel is placed in highly alkaline condition, it is not going to corrode. Such a condition is known as passivation. In actual practice, carbon dioxide present in the atmosphere in smaller or greater concentration permeates into concrete and carbonates the concrete and reduces the alkalinity of the concrete. The pH value of the pore water in the hardened cement paste, which is around 13, will be reduced to around 9 by the carbonation, ingress of the carbonates. When all the calcium hydroxide has become carbonated, calcium hydroxide is liberated by the action of the hydration process of the cement. This calcium hydroxide is reacted with the carbonic acid and forming calcium carbonate. So when all the calcium hydroxide has become carbonated, the pH value will reduce to about 8. If such a low pH value, the protective layer gets destroyed and the steel is exposed to corrosion. Steel is exposed to corrosion. So the carbonation of concrete is one of the main reasons for corrosion of reinforcement. So carbonation of concrete is one of the main reasons for corrosion of reinforcement. Another cause is chloride ingress. We will see the chloride ingress later. The carbonation of concrete is one of the main reasons for corrosion of reinforcement. Of course, oxygen and moisture are the other components required for corrosion of embedded steel. Measurement of depth of carbonation. A common and simple method for establishing the extent of carbonation is to treat the freshly broken surface of concrete with a solution of phenolphthalein in diluted alcohol. If the calcium hydroxide is unaffected by CO2, the color turns out to be pink. If the calcium hydroxide is unaffected by the carbon dioxide carbonation, the color turns out to be pink. So pink color formation is denoting a very good concrete. If the concrete is carbonated, it will remain uncolored. So the uncolored concrete means the color change is not there, means automatically the concrete is subjected to carbonation and leading to corrosion of the disintegration or corrosion of the reinforcement, etc. So it should be noted that the pink color indicates that enough calcium hydroxide is present, but it may have been carbonated to a lesser extent. So if the carbonation is there, it is at the lesser extent. It will not come to the corrosion of the reinforcement. So that is the pink color indicates is very, very important. The color pink will show even up to a pH value of about 9.5 or 10. So this figure shows the value. This color indication, pink color indication means this concrete is not affected by the carbonation, whereas here uncolored concrete, this is affected by the carbonation. Pink color indicates that calcium hydroxide is unaffected by carbonation. The uncolored portion indicates that concrete is carbonated. So the depth of carbonation is very, very important because of this action. Sulfate, water and carbon dioxide, this will try to attack the surface of the concrete, and the depth of the carbonation is affecting this concrete cover. If the concrete cover is enough, very large, then only the portion of the cover concrete is affected by the depth of carbonation, and there is still concrete cover is there. This cover of the concrete has a pH value is about 11 or 12. So it will protect the passive layer around the steel reinforcement. So the steel is in a passivative condition. There is no corrosion possible. Concrete is under continuous attack by aggressive environmental agencies. Good concrete and sufficient cover is the answer for the durability. Good concrete means low water cement issue, impervious concrete, high cement content, etc. Good concrete is essential. Similarly, the cover thickness is also sufficient. Chloride attack. Chloride attack is one of the most important aspects for consideration when we deal with the durability of concrete. Chloride attack is one of the most important aspects for consideration when we deal with the durability of concrete. Chloride attack is particularly important because it primarily causes corrosion of reinforcement. Statistics have indicated that over 40% of failure of structure is due to corrosion of reinforcement. Statistics have indicated that over 40% of the failure of the concrete structures. 40% failure of the concrete structure is due to corrosion of reinforcement. So if you arrest the chloride attack or enhance the durability of the concrete, the corrosion of reinforcement is not possible. Once the steel is in passivative condition or concrete is durable condition, there is no failure of the structure. The structure have a very long life, about 100 years, etc. So in order to prevent the failure of the structure, you have to avoid the corrosion of reinforcement or providing a durable concrete, etc. Due to the high alkalinity of concrete, protective oxide film is present on the surface of steel reinforcement. Due to the high alkalinity of concrete, a protective oxide film is present on the surface of steel reinforcement. This protective layer can be lost due to the presence of chloride in the presence of water and oxygen. This protective or passivative layer can be lost due to the presence of chloride in the presence of water and oxygen. In reality, the action of chloride in inducing corrosion of reinforcement is more serious than any other reasons. One may recall that sulfate attacked the concrete, whereas the chloride attacked the steel reinforcement. So sulfate attack, sulfuric acid attack, or chloride attack, etc. Acid attack, etc. attacks the concrete surface, concrete only, by removing the cement paste, etc., deteriorating the concrete, etc. But whereas the chloride attack causes the corrosion of the steel reinforcement. So it is very much important. Chloride attack is to be prevented. Chloride enters the concrete from cement, water, aggregate, and sometimes from a mixture. So if the aggregate contains some chloride content, or if the water contains some chlorides, etc., or if the blended cement is having some amount of chloride content, or admixture, superplasticists or chloride content admixtures, then this chloride enters into the concrete. The present day admixtures are generally containing negligible quantity of chloride, or what they call chloride free. Normally, nowadays, the admixtures, chemical admixtures are all plasticizers and superplasticists are chloride free admixtures. Chloride can enter the concrete by diffusion from environment. The IS standard specifies the maximum chloride content in cement as 0.05% previously, but it is now increased the allowable chloride content to 0.1% as per IS 456. IS 456 2000 is for the durability consideration. That is one, the chloride content is 0.1%. That is the increase in chloride content because of the use of supplementary cementitious atmosphere, etc. Supplementary cementitious material in concrete. Corrosion of steel because of the inducing of the chloride ions. Corrosion of steel in concrete is an electrochemical process when there is a difference in electrical potential along the steel reinforcement in concrete. An electrochemical cell is set up. When there is a differential in electrical potential, that is EMF, electromotive force, along the steel reinforcement in concrete, an electrochemical cell is set up. But electrochemical cell is nothing but one. In the steel, one part becomes anode and the other part becomes cathode connected by the electrolyte. Same reinforcement, one part of the steel is anode and another part of the steel is cathode. So the concrete is acting as an electrolyte. So there will be a flow of electrons in the form of pore water and hardened cement paste. The positively charged ferrous ions Fe++ at the anode pass into solution, while the negatively charged free electrons E negative pass through the steel into cathode. They are absorbed by the constituents of the electrolyte and combined with water and oxygen to form hydraulic ion, OH negative, hydroxyl ions. That is the mechanism of the corrosion. The positively charged ferrous ions at the anode pass into solution, while the negatively charged free electrons pass through the steel into cathode, where they are absorbed by the constituents of the electrolyte and combined with water and oxygen. These are the ingredients, these are the more mediums necessary for the inducing of the corrosion. Water is necessary and oxygen is necessary to form the hydroxyl ions. These hydroxyl ions travel through the electrolyte and combine with the ferrous ions to form ferric hydroxide. Ferrous ions to form ferric hydroxide. which is converted by further oxidation to rust, which is converted by further oxidation to rust. So that is the corrosion mechanism. The steel reinforcement, one part is taking as anode and another part is considered as cathode. So anode to cathode and cathode to anode, the current is passing, that is the potential is forming, that produces OH hydroxyl ions in the presence of chloride ions, chloride inducing corrosion. These are the medium necessary for inducing the reaction, that is oxygen and water. This will include the reaction, that is the reaction of the hydroxyl ion. This hydroxyl ion is flowing through and forming this ferrous oxide to ferric oxide flames, etc., thus preventing the rusting, thus causing the rusting of the steel. It can be noted that no corrosion takes place in the concrete in dry or probably below relative humidity of 60%, because enough water is not there to promote corrosion. As I mentioned earlier, water is medium necessary for promoting the reaction. So if the humidity is below 60%, there will be no corrosion reaction, because enough water is not there to promote the corrosion. Or you have to maintain the concrete is dry condition. It can also be noted that corrosion does not take place if concrete is fully immersed in water, because diffusion of oxygen does not take place into the concrete. Apart from the medium of water, you have required another medium, that is the oxygen. So if the concrete is completely immersed in water, the diffusion of oxygen does not take place. From atmosphere into the concrete. If there is no oxygen, there is no reaction of hydroxyl ion is not produced. So corrosion of the steel reinforcement is not possible. You may think if the reinforced cement concrete is completely immersed in water, there may be corrosion taking place, but corrosion is not taking place because of the diffusion of oxygen is not prevented. There is no oxygen present in the concrete promoting the reaction. Probably the optimum relative humidity for corrosion is 70 to 80%. The product of corrosion occupy a volume as many as 6 times the original volume of the steel, depending upon the oxidation shape. So once the rust is formed and the rust is graduated into corrosion and corroded steel, the volume of the corroded steel is about 6 times increase in volume. So 6 times increase in volume is the surrounding concrete is completely disintegrated, fallen off, and the exposure to the external agent is easily possible. Induction of the corrosion or the corrosion reaction is further and further, causing the corrosion of the reinforcement and complete failure of the structure is taking place. So the product of corrosion occupy a volume as many as 6 times the original volume of the steel, depending upon the oxidation state. That is the very important parameter. So you have to arrest the corrosion. The increased volume of rust exerts thrust on a cover concrete, resulting in cracks, spalling, or delamination of concrete. With this kind of situation, concrete loses its integrity and the cross-section of the reinforcement progressively reduces and the structure is sure to collapse. The cross-section of the reinforcement progressively reduces because the diameter is reducing from 12 mm to 8 mm like that. So with the 8 mm rod, it cannot be satisfy the load carrying capacity. So the structure is failure. Corrosion of steel in concrete. That is the pictorial representation. That is the steel reinforcement. This one is the anodic zone and this one is the cathodic zone. Corrosive active action means a passive active layer film is there, and depending upon the ingress, as chlorides reach the steel, rust forms and can expand 5 to 10 times the volume, causing cracking and swelling. These products, rust products or corroded products, are causing the cracks and spalling of the cover concrete. So easily water, oxygen, or carbon dioxide, or any other external agents easily attacks the surface of the steel. The steel surface is not protected, so corrosion of steel is taking place, and very soon the failure of the structure is expected because of the corrosion. There is another schematic diagram. This is the reinforcement. Cracks have been formed from the reinforcement to the surface of the concrete, and these cracks, via these cracks, the oxygen, water, carbon dioxide, etc., chloride ions, etc., are penetrating, and this will causes the rusting action around the steel reinforcement, and the volume of the steel reinforcement is increased further and further. So spalling of cover concrete is taking place. Spalling of cover concrete is taking place because of the increase in volume is about 6%. 6 times the volume of increase, 100%. So once the cracks have been formed, the delamination of the cover concrete is completely taken place, exposing the steel reinforcement. It is the bottom of the roof slab, expose the steel reinforcements completely, and the rusted steel reinforcement. The cover concrete is completely spalled off. There is no cover concrete at all. Another diagrammatic representation like this. Reinforcement, it causes the cracking and the spalling of the concrete, etc. Cracking and spalling of the concrete. Finally, delamination is taking place. This portion is completely removed. The steel reinforcement is exposed. Electromicrograph showing corrosion in poor concrete. If the concrete is poor, automatically the chloride ions, carbon dioxide, etc., water, oxygen, etc., present, and the rusting of the steel reinforcement is taking place, and corrosion of the steel reinforcement is taking place. That is, the color of the reinforcement is changes to reddish color. But the same electromicrograph showing no corrosion in good concrete. If the concrete is good, there is no impervious concrete, there is no porous section and capillary pores, permitting the chloride ions, carbon dioxide, etc., water, oxygen, etc. So this steel reinforcement is completely protected by this passive film, passive layer, and there is no external agents, etc. Your steel is as it is. There is no corrosion is present. This photograph represents the delamination of the cover concrete. That is, the cover concrete is completely eliminated, and the steel reinforcement is crack formed due to bursting pressure on account of rusting of the reinforcement. Example of delamination of the concrete cover, roof slab. The concrete cover. This concrete cover is about 15 mm. About 15 mm. So this mild concrete is exposed completely. Another diagram showing the induced corrosion. Corrosion induced like this, cracking and spalling of the concrete, etc. That is the condition corrosion ravaged columns. Corrosion ravaged columns. From the literature survey and case studies, it has been reported that 40% of the failure of structure is an account of corrosion of the embedded steel reinforcement in concrete. Therefore, corrosion control of steel reinforcement is subject to paramount importance. 40% of the failure is due to corrosion, so corrosion control is very, very important criteria. First and foremost for corrosion control is the good quality of the concrete through the good construction practices. It is a very vast subject that touches the fundamentals of choosing construction material and good rules to be followed at various stages and production of concrete. In particular, the use of lowest possible water cement ratio, having regard to workability, in view of the general availability of super plasticity, it should be used to cut down the water cement ratio to make density concrete. Normally, according to IS 456 or IS 10262 code product practices, the 20 mm aggregate requires about 188 liters of water to make the concrete, mixing water, 188 liters. If you use super plasticity, you can reduce 30% of water. So only 150 liters or 150 kg per meter cube of water is sufficient for making the concrete. So if the water is reduced, automatically water cement ratio is reduced. So it will produce a good quality of the concrete. That is for the durability purposes. It should be used to cut down the water cement ratio to make dense concrete. Proper mix design, use of right quality and quantity of cement for different exposed conditions is to be adopted. Use of supplementary synthesis materials such as fly ash, ground granulated blast furnace like GGBS, silica fume, microsilica, etc. are required to be used as admixture mineral mixtures or in the form of blended cement, PVC or blended cement, in addition to the lowest possible water cement ratio to make concrete dense. So this is the condition. Use of the supplementary cementitious materials or blended cement is required with along with lower water cement ratio to make the dense concrete or impervious concrete. These materials improve more than one properties of concrete, which will eventually reduce the corrosion of reinforcement. Tests on concrete or mortar containing GGBS have shown that water permeability is reduced by a factor of 100. So 100 times lesser permeability is there. Water is concrete is completely impervious. It is also reported that 60% GGBS reduce the diffusion of chloride ions into the concrete by as much as 10 times. Chloride ions also reducing about 10 times. Silica fume contributes to the all-around improvements in the quality of concrete, which are responsible for reducing corrosion of the steel reinforcement. Micropore structure is improved, very much improved by means of adding silica fume. That is very, very lesser micron size particles. So automatically the corrosion is reduced. The improvement in the microstructure of hydrogen cement paste is ultimately responsible for protecting the steel reinforcement from corrosion. The improvement in the microstructure of hydrogen cement paste is ultimately responsible for protecting the steel reinforcement from corrosion. In short, it can be said that if we make good concrete with low permeability and improved microstructure, it will be durable by itself, and also it can take care of the reinforcement contained in it to a great extent. So, if you want longer life of the structure, about 100 years or 200 years, etc., you have to prevent the corrosion of the steel reinforcement. It will be done by durable concrete. What is durable concrete? Good concrete with low permeability and improved microstructure. That is the durable concrete. It is always not possible to make such ideal concrete, particularly in view of the complex environmental and exposure condition. Further, in the inherent long-term drain shrinkage and microcracks in concrete, the problems become more serious. This demands certain other measures to control the corrosion of steel reinforcement. They are listed as below. Metallurgical methods, corrosion inhibitor method, coatings reinforcement, cathodic protection method, coatings to concrete, design and detail. These are the corrosion control methods. We will see one by one. Metallurgical methods. Steel can be made more corrosion resistant by altering its structure through metallurgical process. That is the pure mechanical or the metallurgical process. Steel can be made more corrosion resistant steel can be produced. Different methods such as rapid quenching of the hot bars by series of water jets, or by keeping the hot steel bars for a short time in a water bath, and by such other process, the mechanical properties and corrosion resistant property of the steel can be improved. These are the quenching and tempering, etc. That is the mechanical process or the metallurgical process to improve the properties of the steel. There are many situations where stainless steel reinforcements or the corrosion resistant steel reinforcement are used for long-term durability of concrete structures. Corrosion inhibitor. The next step is corrosion inhibitor. Corrosion can be prevented by or delayed by chemical method by using certain corrosion inhibitant chemicals such as nitrates, phosphates, benzonates, etc. Of the available material, the most widely used admixture is based on calcium nitrate. Of the available materials, the most widely used admixture is calcium nitrate. It is added to the concrete during the mixing of concrete. The typical dosage is 10 to 30 liters per meter cube of the concrete, depending on the chloride levels in concrete. One of the corrosion inhibitor is calcium nitrate. If you add this corrosion inhibitor inside the concrete while mixing of the concrete is taking place, this will take care of the corrosion resistant mechanism. As mentioned earlier, if the high pH value of the concrete, the steel is protected by a passivating layer of ferric oxide on the surface of the steel. However, the passivating layer also contains some ferrous oxide which can initiate corrosion when the chloride ions reach the steel. The nitrate ions present in the corrosion inhibiting admixture will oxidize this ferrous oxide to ferric oxide, thus stabilizing the passivating layer even in the presence of chloride. So the ferrous oxide is completely converted into ferric oxide by means of this calcium nitrate ions, corrosion inhibitor admixtures, stabilizing the passivating layer. So passivating layer is there means there is no corrosion, there is no chloride attack, etc., chloride diffusion. The concentration of nitrate must be sufficient to cope up with the continuing ingress of chloride ions. Next step is coating to reinforcement. The object of coating to steel bar is to provide a durable barrier to aggressive flows. The coating should be robust to withstand fabrication of reinforcement cage and pouring of concrete and compaction by vibrating metal. The coating should be robust to withstand the fabrication of reinforcement cage and pouring of concrete and compaction by vibrating metal. The coating will not be affected through this process, compaction and the pouring process. Simple cement slurry coating is a cheap method for temporary protection against rusting of reinforcement in storage. Central Electrochemical Research Institute, Karaikudi, have suggested a method for prevention of corrosion steel reinforcement. The steps are de-rusting, phosphating, cement coating, and sealing. De-rusting, the reinforcements are then cleaned with a de-rusting solution. This is followed without delay by cleaning the rods with the wet waste cloth and cleaning powder. The rods are then rinsed in running water and air. Reinforcement is completely rinsed in running water and air. Phosphate jelly is applied to the bars with a fine brush. The jelly is left for 45 to 60 minutes and then removed by wet cloth. An inhibitor solution is then brushed over the phosphated surface. Cement coating. A slurry is made by mixing the inhibitor solution with Portland cement and applied on the bar. A sealing solution is brushed after the rods are air-filled. This sealing solution has an inside curing effect. The second coat of slurry is then applied and the bars are air-dried. Cement slurry coating is made by mixing the inhibitor solution with Portland cement and applied to the bar. 2 coats of sealing solution are applied to the bars in order to seal the micro pores of the cement coat and to make it impermeable to corrosive soil. So this is the view of the cement polymer composite coated rebars. This polymer coated rebars are stored in your storage yard and then used for the fabrication of the steel reinforcement for making concrete structure, RCC structure. The other method is epoxy coated bar. It is one of the effective method of coating the rebars. The fusion bonded epoxy coating is a specialist job carried out in a factory or not at site work. Plants are designed to coat the straight bars in a continuous process. Initially, the bar is hot blasted to remove all mill scale and to give the kind of surface finish required. This ensures an adequate bond between the epoxy and the steel. The bar is then heated to a carefully controlled temperature before passing through a spray board. Electrostatically charged epoxy powder particles are deposited evenly on the surface of the bar. Electrostatically charged epoxy powder particles are deposited evenly on the surface of the bar. It looks greenish in color. The coating thickness may vary from 130 to 300 microns. The thickness of the coating is about 150 microns, 0.15 m. Galvanized reinforcement. Another technique is galvanized reinforcement. Galvanizing of reinforcement consists of dipping the steel bars in molten zinc, This results in a coating of zinc bonded to the surface of the steel. The zinc surface reacts with calcium hydroxide in the concrete to form passive layer and prevents corrosion. The zinc surface reacts with calcium hydroxide in the concrete to form a passive layer and prevents the corrosion. That is why GI steel is provided for the reinforcement. Unprotected steel reinforcement, corrosion is taking place and spalling of concrete exhibiting the reinforcement, rust formed reinforcement. If you provide a galvanized steel, there is no corrosion, there is no rusting action, etc. Because of the strong passivity layer provided by the zinc reacted with the calcium hydroxide solution liberated from the hydration setting action of the cement. Another method is cathodic protection. Cathodic protection is one of the effective, well-known and extensively used methods for prevention of corrosion in concrete structures in more advanced countries. Due to high cost and long-term monitoring required for this method, it is not very much used in India. The cathodic protection comprises of application of impressed current to an electrode laid on the concrete above the steel reinforcement. This electrode serves as an anode, sacrificial anode, and the steel reinforcement, which is connected to the negative terminal of a DC source, acts as a cathode. In this process, the external anode is subject to corrosion, and the cathodic reinforcement is protected against corrosion, and hence the name cathodic protection. The other name is sacrificial anode. You have to provide sacrificial anode above the reinforcement, and this sacrificial anode is completely washed out along the period of that time. You have to replace once in 2 years or 3 years, etc. So monitoring is done, periodical monitoring is done, and you have to replace or provide the cathodic protection. This figure shows like this. You have to insert the sacrificial anode nearby the reinforcement. This sacrificial anode consists of easily reactable component ingredient, and so only because of this corrosion, only this anode is completely de-rust and corroded. The reinforcement is completely protected. In addition to the coating reinforcement by appropriate material, a surface coating to the concrete member is given to increase the durability of all. The coating serves the dual purpose of protection and decoration. Giving protective coatings to a major concrete structures such as bridges, flyovers, industrial buildings, and chimneys have become a common specification in India as in other countries. Nowadays, you can see the concrete bridges or flyovers, etc., or all other buildings, etc. This have a decorative coating. This protective coating is preventing the ingress of the external agents. So durability of the concrete is improved. 4-kilometer long bridge on a national highway at Cochin was recently coated with Yemi color flags, a material manufactured by MS Beckham Limited. Nowadays, all the bridges are coated with these materials. So coating is done, so the concrete surface is done by this people. So this is the view of the coating. Acrylic-based protective decorative coating is given to the JG flyover and to many other bridges and flyovers in India, particularly the coastal regions, and not in particular coastal areas, but in odd areas, to increase the durability of the concrete. Design and detailing. The structural designer should take all precaution in designing and detailing with respect to spacing between the bars for the concrete, to flow between reinforcement, to facilitate vibration of concrete, to give proper cover to the steel reinforcement, to resist the crack width, etc. So you have to follow strictly the codal provisions for the detailing of reinforcement. According to IS 456 or IS 13920, etc., and you have to strictly adhere the spacing between the main bars, spacing between the stirrups or tie bars, etc. It facilitates the vibration of a concrete to give proper cover to the steel reinforcement, etc. To restrict the crack width. Closer spacing of the reinforcement means the crack width is automatically reduced. Nominal cover to reinforcement. The nominal cover is applicable to all steel reinforcement, including links. For longitudinal reinforcing bars in a column, nominal cover in any case not less than 40 mm or less than the diameter of the bar. In the case of columns of minimum dimension or 200 mm or under roofs, reinforcing bars do not exceed 12 mm. A nominal cover of 25 mm will be used. So normal cover for the slab, etc., or if the bar is not exceeding 12 mm diameter, 25 mm cover is sufficient. Or if the bar diameter is 16 mm or 25 mm, etc., a 40 mm cover should be needed. Minimum dimension is 200 mm. Crack width. Some specifications limit the crack widths at points near the main reinforcement instead of a surface. International Processing Federation FIP recommend the maximum crack width at the main reinforcement to be 0.004 times the nominal cover. If the nominal cover is 50 mm, the crack width at the surface comes to be 0.0004 into 50, that is 0.2 mm. So the crack width is about 0.2 mm, that is allowed. If it exceeds, then you have to prevent the cracks. Crack widths at the surface play an important role in the durability of the concrete structure. The structural designers should understand and give serious considerations while designing the structure. So, limit set of serviceability for the deflection criteria is essential for the structural engineer for the high strength concrete members, but the limit set of serviceability criteria for the crack width is very, very important for improving the durability of the concrete structures. So these are some of the instruments to measure the crack width. So what is the importance of the corrosion of the concrete structures? That is the concrete platform for conveyor belts and pipelines across the sea for the thermal power plants. Conveyor belts and pipelines are provided for the thermal power plants or offshore platforms, etc., for transporting the oil, etc. And sometimes the bridge is movable for the vehicles, etc. So when the vehicles moves, there will be cracks develop, and in addition to the seawater, corrosion will be there. So concrete platform is subjected to corrosion activities, crack widths are high. Because of this, concrete decks exposed to marine environment, corrosion takes place. There are severe cracks developed at the concrete surface. You have to avoid these cracks. Once the crack widths are not noticed and the corrosion of the steel reinforcement is not noticed for a long time, finally the failure of the structure takes place. This is due to the failure of the corrosion of the steel reinforcement. On the corroded deck, the steel reinforcement is visible, and over a period of time it loses its capacity, and finally failure will be taking place. Normally, the construction of concrete piles in sea waters and etc. will be subjected to the chloride attack present in the sodium chloride ions present in the seawater, and so you have to use only the durable concrete. Now, these are some of the experimental investigations taken up in IRTT. One of the PhD thesis under my guidance is durability of tower foundations, transmission line tower foundations, done by Christian Johnson. So the methodology adopted is design of concrete mix of M20 grade with the mineral admixtures to increase the durability of concrete. The specimens are subject to the acceleration corrosion testing in order to find the initiation of the corrosion period and the corrosion level damage. Various corrosion protection techniques, that is coatings, etc., have been tried for improving the durability of concrete or increase the protection of the steel against corrosion. Various methods are adopted. The specimens are subjected to rapid chloride ion penetration test in order to study the effectiveness of the corrosion protection method. Because the corrosion is possible with chloride inducing. Because the chloride induced corrosion is very, very dangerous. So this can be experimented by RCPT tests. Suitable suggestion measures obtained from the laboratory investigations are recommended to the field while constructing the foundation. Construction of the foundation of the tower line. The specimen is fixed between the two reservoirs using an epoxy bonding agent to make the test setup at a low lake. One reservoir is connected to the positive terminal of the DC source and it is filled with 0.3 molar solution, sodium hydroxide solution, NaOH. And the other reservoir is connected to the negative terminal of the DC source and it is filled with 3% sodium chloride solution, NaCl solution. One portion sodium hydroxide and another portion sodium chloride. So there will be a diffusion of chloride ions from one portion to another portion via the concrete. A DC voltage of 60 volt was applied across the specimen using two stainless steel electrodes, and the current across the specimen was recorded every 30 minutes intervals for 6 hours. This is the apparatus, that is the reservoir. One reservoir is filled with sodium hydroxide solution and another reservoir is filled with sodium chloride solution, and in between these two cylinders, concrete specimen is taking a place with the epoxy joint, to another to leak proof, and for extra leak proof, some adhesive tapes are provided. One electrode is provided here and another electrode is provided here. Between the electrode 60 volt current is DC current is passed. Because of this, chemical reaction is taking place and chloride is transferring from this place to this place via the concrete. So the concrete is subjected to chloride induction, chloride ion penetration. That is why it is called as a rapid RCPT test, rapid chloride ion penetration test. The different specimens are with different coatings. The specimen 1 is plain concrete without any flares or any supplementary synthesis material, ordinary concrete without any coating, etc. The second is with the supplementary synthesis material. Third is with chemical admixture also, superplasticization. 4 is with corrosion inhibitor agents, calcium nitrate solutions. With 5 is fiber reinforced concrete. And specimen 6 and 7 are provided 2-level coating with flexibond SCSR, DMAC coating on the steel reinforcement as well as on the concrete surface. And 3-level coating with the nano-Zika seal means the nano-Zika seal is coated with the surface of the concrete, and the surface of the steel is coated with one material, and the concrete is mixed with admixtures, mineral and chemical admixtures. That is with 3-level coating. The RCPT test, the specimens are cut into small pieces, 150 mm diameter and 50 mm height, thickness, 52 mm thickness, and the view of the closer view of the specimen. These are the specimen with the coatings, different coatings, and it is placed on the test setup like this. Now the current is passed, that is the voltage is passed. The current is measured at every 30 minutes, each and every 30 minutes. The current in milliampere is measured by means of multimeter or impedance meter up to 6 hours, 360 minutes. And the total charge passed during this period was calculated in terms of coulombs using the trapezoidal rule as given in the SESSION standard. Q equal to 900 into I0 plus twice I30 plus I60 plus I30, etc. up to the last, and then where Q is the charge passed, I0 is the current immediately after the voltage is applied, IT is the current at T minutes after the voltage, I30 minutes after 30 minutes, I3 30 minutes after 330 minutes, the current passed milliampere. So it gives the total coulombs, total charge pumps in terms of the coulombs. There is one standard given by the SESSION standard. If the charge passed is above 4000, high permeability is there, high penetrability of the chloride ion is there. There is less permeable, there is durability is very, very less. The chloride ion easily penetrate into the concrete. 2000 to 4000 moderate penetrability. 1000 to 2000 low permeability, 100 to 1000 very low permeability, less than 100 negligible. So this is the standard prescribed by SESSION standards. So we have to make a concrete like this, negligible or very low permeability is there. We should not go for high and moderate. Our experiment shows for each and every specimen, the total charge passed is about 4,000. That is high penetrability is there. It is a controlled concrete. If admixture is used, slightly less moderate permeability, penetrability, 2000. So if mineral admixture and the superplasticities or chemical admixtures are produced, more or less same thing, 2000 moderate permeability, penetrability. If corrosion inhibitor is used, it will not give any effect for this penetrability, chloride ion penetrability. It is only for the corrosion resistance, not the chloride ion penetration. So once again, high penetrability is there. Recron 3S fiber, polyester fibers are added. This also will not give any proof to the resistance to the penetrability. So it is much more higher because of lot of voids are there. Permeability is much more higher than conventional concrete. That is why the Q value is much more higher, high permeable penetrability. But if you provide 2-level coating or 3-level coatings, etc., it is under the low category, less than 2000 penetrable values. Low category, low penetrability is there. If you use nano Zika cell, if the penetrability is less than 1688, very low penetrability, it is good. So specimen 8 coating is 3-level coating with the nano Zika cell is adapted for the highly aggressive environment regions to protect the steel products. This is a pictorial view. The water is standing on the surface of the water. It will not penetrate into. So water particles stand as on lotus on the surface coated with Zika cell. Tamara ilai thanni maadhiri mele ulla pogadu. So conclusion is 3-level protection specimens exhibits excellent performance because it deeply penetrates into the substrata and offers good resistance to corrosion. Accelerated corrosion test. The half cell is a hollow tube containing copper electrode and immersed in copper sulfate solution. The bottom of the tube is open and covered with a sponge material. The copper sulfate solution permeates through the sponge that can then be placed on a concrete surface, allowing the electrical potential to be measured. The objective of the method is to measure the voltage difference between the rebar and the concrete over the rebar. Large negative voltages, minus 350 millivolts, indicate that corrosion may be taking place. Voltages smaller than 200 millivolts generally mean corrosion is not taking place. A typical half cell setup is shown in the figure. This is a view. Concrete surface, reinforcing bar. This reinforcing bar is connected by means of a wire to the high impedance voltmeter positive terminal. And the surface of the concrete, this is the half cell potentiometer, sponge material for the penetration of the fluid, and this electrode is connected to the negative terminal. So there is a indication of the millibar. This is the multimeter, voltmeter, it gives the indication. Half cell potentiometer. Now the specimens are concrete specimens, cylindrical concrete specimens are cast with steel angles or steel rods embedded up to a certain depth, and these steel rods are connected by means of wires and the positive terminal of the voltmeter. Positive terminal of the voltmeter. Oh, sorry, it is the power part, DC power part, 60 volt current. Sorry, 12 volt current is applied. And it is measured by means of digital multimeter or analog multimeter. One surface is touching, steel surface is touching, and another is through half cell. This is consisting of copper electrode and copper sulfate solution, and this copper sulfate solution is passing through the concrete electrolyte, and the electric half cell is completed. Because of this complete cell action, this reading is taking place. 148. 148 means there is no corrosion at all. There is no corrosion at all. Another technique is impressed voltage technique. This is also an accelerated corrosion test, but we are measuring only the current. The variation in development of corrosion current was monitored at regular intervals using a high impedance multimeter. The time required for the relative resistance of coating material against chloride ingress and subsequent corrosion. Another test is applied voltage test. The effect of electrical and electrochemical resistance on the bond of coating material to steel and no film integrity of the coating shall be assessed. A non-conductive plastic material shall be used for the vessel for lining in a metallic vessel. The cathode and the anode shall be the reinforcing bar or the angle coated with the proposed material. The electrolyte shall be an aqueous solution of 7% NaCl. A potential of 2 volts shall be applied. There are different specimens, epoxy coated and the FACS are coated, DMAC coated angles, corrosion inhibitor cement slurry coated angles, etc. Uncoated steel angle for the comparison purpose, etc. To be a good coating film, no film failure is evidenced by evaluation of hydrogen gas at the cathode or appearance of corrosion products of iron or the anode shall take place during the first hour of testing. So, by application of 2 volt current, we cannot notice the hydrogen gas evolution at the cathode or the corrosion product of iron at the anode level. It will be a good coating material. So, this is the schematic diagram, picture review of the specimens connected to the voltage systems. These specimens are inserted in the solution of the water, sodium chloride solution, 7% sodium chloride solution for a particular time. Chemical resistance test. Most acid solution will slowly or rapidly disintegrate Portland cement concrete depending upon the type and concentration of acid. Certain acids such as oxalic and sulfuric acid are combined. The most vulnerable part is COOH12, COOH twice, that is called cement oxide. As the attack proceeds, all the cement compounds are eventually broken down and leached away together with any carbonate aggregate material. The chemical resistance setup is evaluated by immersing coated reinforcing steel angle in each of the following: distilled water, 3 molar aqueous solution of calcium chloride, 3 molar aqueous solution of sodium hydroxide. So these are the coated angles, these are immersed in the solution. And the result is the performance index point is calculated according to the codal practice IS 13920. The code is 13620 code. IS 13620 code. Performance points are calculated. You can plot that. This plain uncoated angles are having only the 10 performance index, whereas the DMAC coating is up to 20%. Against 3 molar sodium hydroxide solution and like that. Similarly, FACR and CS cement slurry coated, etc. also present. The performance of epoxy coated is slightly less. That is another investigation, different coating, plain angle plus plain concrete, plain angle plus unmixed concrete, coated angle plus unmixed concrete, coated angle plus conventional concrete, plain angle plus conventional concrete plus external coated bar, etc. like this, up to CS10. The different types of variables are available. So, conducting the accidental corrosion test over a period of 500 hours or 400 hours. This coated bar is taking more time for making the corrosion, inducing the corrosion. For inducing the corrosions, 470 and 438. Whereas the conventional concrete, plain concrete, minus 350 within 100 hours period. So corrosion is taking place within 100 hour period time, whereas the coated angles are subjected to about 300 to 400 hours. Similarly, impressed voltage readings, it also indicates the coated angle, 2 level coating or 3 level coating are giving the performance index as per this. Applied voltage type of coating, 2 level coating or 3 level coating with cement slurry or a chemical coating, epoxy coating, plain angle, uncoated angle. For the uncoated angle, innumerable rust spots are available at the anode points. and a vigorous evolution of the hydrogen pass at the cathode point. 2-volt current is applied. So at the cathode point, hydrogen gas is evaluated, and at the anode point, rust spot is formed. This is plain angle. Similarly, if epoxy coating is provided, this inevitably is restricted to light rust, and a vigorous evolution of this is light evolution. But still there is an evolution of the hydrogen gas. But for other coatings, with the chemical coating or cement slurry coating, no corrosion products of iron at the anode level, no evolution of hydrogen gas at the cathode level, as per the previous indications. Now, a transmission light tower is fabricated as a model, and the 4 legs of the tower, the foundation is cast, and this foundation is subjected to different coating level, coating to steel, coating to concrete, with admixture concrete, with some modification, etc. And it is subject to accelerated corrosion by means of dumping into a solution, water solution with 3.5% NaCl solution, and with the help of DC power pack, corrosion is induced. In this model tower, the best protective coating through the laboratory tests was supplied over the foundation legs. Different coating MTF 1, 2, 3, 4, etc. These are different coating level. Corrosion was induced by the acceleration by using DC power pack. Rate of corrosion for every 50 hours was monitored through a half-cell potentiometer reading. By comparing the results, best protective coating technique has been identified. So, with plain angle, about 200 hours, the corrosion is initiated, and it is propagated up to 563 or 600, etc., beyond the 500 hours period. But if coating is provided, FACSR coating or DMAC coating, etc., it will take, the initiation of corrosion is taking place only after 500 hours, not at the 200 hours. It is taking place only after 500 hours. And the propagation period demands about 1000 hours duration, or 500 or 700 like that. This cement slurry coating is slightly not performing, and it crosses this limit by 250 hours. Slight better, but inferior to this 2-level coating or 3-level coating, etc. The impressed voltage performance also the same thing. The coatings with the 2-level or 3-level is better as compared to uncoated angles. Effectiveness of protein. The inclusion of corrosion inhibitor delays the initiation period considerably. 3-level protection for the legs of the model tower exhibits no corrosion even up to 500 hours of accelerated corrosion. The leg coated with a nano-zirconium penetrating is not at all affected by the corrosion mechanism. So it is concluded and recommended that there is a need for applying 3-level coatings like polymer-based coating on stub angle, addition of fly ash by replacing cement by 20%, and addition of superplasticity in the concrete about 1%, and surface coating to the concrete surface by chemical FACR or DMAC or any other coating in the legs of the transmission line tower foundation to increase the durability of the tower foundation. So in order to increase the durability of the tower foundation, we have to adopt a 3-level coating method. One is coating to the angle, and another is coating to the surface of the concrete. Third is durable concrete. Another experimental investigation, reinforced concrete column. Column is specified, and it is subjected to the corrosion in the corrosion chamber. DC power pack, using the DC power pack, corrosion is induced, rust formation is taking place. The reinforcement inside the columns are heavily corroded, and this is the view of this leaching of the corroded products. And after that, the columns are tested in the compression testing machine, short columns and the long columns, and the structural behavior of the corroded columns is assessed. This figure shows uncorroded column is 650 kN is ultimate load carrying capacity, whereas for the corroded column, only 540 kilonewton is the load carrying capacity. So the load carrying capacity of the column is highly reduced. Similarly, corrosion of concrete with various admixtures. The concrete is consists of various admixtures. Casting of concrete cylindrical specimens with the rebars and subjected to accelerated corrosion setup by means of accelerated corrosion or inducing EMF. That is a pictorial diagram. Concrete cylinders are there. This is the silver plate solution, that is the cathode, and it is a non-conductive sodium chloride solution. And this stainless steel plate is connected to the negative terminal of DC power plant, and this embedded steel reinforcement is connected to the positive terminal. So once you apply the 12 volt or 6 volt current, means the current solution, current transformation, the circuit is completed, and the cathode and the anode are affected by means of this current circulation, and corrosion taking place. This is the photograph of the test setup. It is also called a polarization. This is a view of the concrete specimen after the corrosion. Specimen shows after correct initiation and propagation under the polarization test. Steel reinforcement is highly corroded and the leaching of the rust solution. The time for initiation propagation of the concrete specimen embedded with the rebar tested under accelerated condition indicates that the lower grade lower concrete has got a less initiation period. When the concrete cover is increased, the initiation that
இந்த டேட் மட்டும் ஒன்று வாங்கணும். இந்த உங்கள்கிட்ட இருக்கா இந்த லாக் புக் என்னைக்கு ஆரம்பம் என்னைக்கு முடியும் டேட்?
Another experimental investigation on the with the same setup, accelerated corrosion setup. That is the test setup, acceleration corrosion test. It is replaced in the chamber and the corrosion is induced, and the view of the corroded specimens. And these specimens are tested by using the non-destructive testing techniques: rebound hammer test, ultrasonic pulse velocity test, offset potential test, current readings, crack width, etc. Ultrasonic potential velocity test. The voids of density, the imperviousness of the concrete is estimated and the strength of the concrete is estimated. So both the corroded specimen as well as uncorroded specimen indicates more or less the same velocity. But rebound hammer is also showing the strength is not affected by means of this corrosion, not very much, only about 20 to 20% less strength is adopted. But half cell potentiometer indicates that the corrosion damage level, that is a field application, that is a laboratory application, half cell potentiometer, and it is indicated in the multimeter. As I mentioned earlier, severe corrosion greater than 500 millivolts or 350, high corrosion limit greater than -350 millivolts, medium corrosion greater than -200 millivolts, and low corrosion less than -200. That is higher positive ranges. That is AFG standard. There are two types of electrodes: copper electrode and silver electrode. Copper sulfate solution and silver chloride solution on that. So this chart indicates this half cell values after a specified period of corrosion. Over the number of days, the corrosion level reaches the ultimate limit and all the reinforcement is getting covered. The columns may be covered with a wrapping, CFRP wrapping or GFRP wrapping, and then provided as a strengthened column or the rehabilitated column. Rehabilitated column means corrode damaged column is covered with the wrapping. Strengthened column is the plain columns are covered with the wrapping in order to prevent the ingress of water and other things inside the column. This is the solution method of fabricating. J for the wrapping and there is a load deflection behavior or a stress strain behavior of the concrete with and without wrapping. For corroded and wrapped columns, corroded column means this one lower stresses and wrapped column means higher stresses. These are the damages for the uncorroded columns. If the wrapping is provided, then there is no damage to the column. There is no severe loss in the integrity of concrete due to corrosion, as the reduction in UPV is only 10%. Say for wrapping enhanced the axial load characteristic of corroded RC column, the increase was in the range of about 15%. GFRP is same thing. Another experimental studies with and without GGBS solution, cement replacing materials. Sulfate attack solution, sulfate attack, corrosion attack, and chloride attack, etc. are formed. Corrosion accelerated corrosion test setup, measuring the half shell potential values, and pull-out strength is established after for the corroded column and the uncorroded column, etc. That is the failure pattern. Chloride RCPT test or chloride penetration test is another test is performed, which is not RCPT test, it is test penetrated by means of solution, so chloride solution. So it is indicated by means of this solution. Applying the solution, the color indication gives these values. Scanning electron microscope of the failure surface is carried out, taken out. Clear indication have been obtained with the presence of hexagonal crystals of calcium hydroxide and calcium monosulfate aluminate hydrate in the hydrated cement system. The generated morphology calcium silicate hydrate gel is dependent on various factors such as hydration period, water solid ratio, etc. So the discussion of the result also performed the same thing with the G20. G20 means admixture concrete. G means GGB solution. So it will automatically gives good durable concrete in all respects. So for the durability of the concrete, you have to add some cementitious material, supplementary cementitious material, just as fly ash or GGBS or microsilica. Chloride attack, it is very, very effect on the chloride attack. M20 concrete and the M30 concrete. The reading is lower concrete, grade concrete subjected to percentage of weight loss higher, and here the percentage of weight loss is lower. Half shell potential reading is also exhibiting the same phenomena. Pull-out strength is also indicates that there is not much strength and degradation between the admixture concrete and the applied concrete. This chloride penetration is also giving the same results. Depth of penetration is also. Scanning electron microscopic figure shows that it is up to 500 or 2000 magnification. This is for G20 and this is for M20. If the magnification is about 2000, you can notice the formation of CS gel, etc. for M20 concrete also, and for the G20 concrete, admixture concrete also. We just compare these two figures. The black hole is watts. Here the blacks is very limited and the gel formation is very, very high, up to the maximum percentage. This is for M30 concrete, high strength concrete, G30 concrete, 2000 magnification gel formation, like this. So based on this, the conclusion is slag concrete is offering a very good resistance against sulfate effect because of the reinforcement of the pore structure. Half shell reading clearly shows that the slag concrete offers much more resistance to the corrosion induced by the current. Please conclude that the addition of GGBS as 40% CRM offers a very good resistance against corrosion attack. Chloride penetration test indicates the presence of GGBS offers more resistance against the chloride attack, thus resulting in less weight loss. The photograph taken by the SEM technique clearly shows that the structure of the slag concrete is non-porous, containing more gel formation. Because of this, the properties such as density, strength has been very much improved. At the same time, the durability properties such as water absorption, chemical crack are very much less. The effect of GGBS is more in M30 grade concrete as compared to M30 concrete. So high grade concrete will exhibit more durable concrete. Based on this, it is concluded that to achieve a more strong and durable concrete, the addition of mineral admixture such as GGBs is essential. It is a waste material obtained by the steel industries. No cost is there, but at the same time, the addition of GGBs will result in more durable concrete, thus increasing the life of concrete structures. So, for obtaining the durable concrete, you have to adopt supplementary cementitious material, low water cement ratio, good quality of concrete, and coating methods or corrosion control methods, etc. This will ensure the durable concrete and enhancing the life of the concrete. So thank you very much for the nice, pleasant listening. If you have any doubt, please ask them. I will ready to answer the questions.
Thank you, sir. Now the floor is open to participants. If you have any doubt or any clarification, you can ask.
Most of our teaching staff members are teaching the subject concrete technology to our undergraduate students or postgraduate students. Hereafter, at the time of giving the study materials to the students, you will ensure or give the importance of the durability of the concrete. Once he will make the durable concrete for the concrete structures, automatically the life of the structure is increased very much, and economical loss is avoided. So it is for the socio-economic benefit of our nations. So we have to build up the structures with a durable concrete.
Thank you, sir. Professor has covered factors influencing durability, corrosion-resistant methods, coatings to reinforcement, coatings to concrete, durability of transmission line tower foundation, case studies, experimental investigation in laboratory. He covered a lot. If you have any further clarifications, you can contact him. For research work, you can ask, you can get clarified any doubts related to all your PhD works. He's having helping tendency. You can contact him at any time. Thank you very much, sir. Thank you, participants. Now the session is over. Next session will start by 11:15. So you please have a break and please join by 11:15 a.m. Thank you very much, sir.
Thank you. Thank you very much.